Hi everyone, and thank you for coming. So my name's Jamie. I'm a mobile architect at Embrace. So effectively I work across our SDKs, and today I'm going to be talking about Android Vitals and why you should care about them. So I guess the first question is, why are we here? So this is basically all to do with Google's system for ranking apps. So you could have a really great app which has great search results, like at #1 in your category. But if you have poor Android vitals, then Google will downrank you. So you're much lower on the search results and you don't show up as a featured app. And that leads to obvious consequences. So your daily active users start going down, in-app purchases and revenue might go down. And Android Vitals is effectively the way that Google the mechanism that Google uses to track how well your app is performing. And seeing these core metrics, so the stuck partial wait locks, ANR rate, excessive wakeups, and crash rate, is really important because they can affect your revenue and ultimately your success as a company. So there's this concept of a bad behavior threshold, which we'll go over a bit later. But if you've looked at ANRs at all, this will probably look quite familiar to you. And effectively, you're allowed a certain budget where a certain amount of things can go wrong. So for ANRs, it's commonly 0.47% of your sessions can go wrong, which doesn't leave you too much margin for error. Let's quickly run over the agenda of what we'll be talking about. So we're going to start off with talking about some of the vitals which Google doesn't necessarily consider core vitals, which you should focus on, but we think they're interesting and that you should know about them nonetheless. Our first core vital, which we're going to talk about, is excessive wakeups. So that is effectively when your device or a user's device is being woken up too frequently due to an excessive amount of alarms, and that drains the battery. Core Vital 2 is also a problem which drains the battery. So if you take out a wake clock and it gets stuck, either in the foreground or the background, then that can be very bad for performance, and it can leave you with a frustrating experience where you run out of charge before the end of the day. The next two vitals are probably something that most of you will be familiar with. So there's crash rate, the number of crashes which your application experiences versus the number of daily sessions, and ANR rate. So that's effectively a measurement of the responsiveness of your application and how frustrated your users might be getting when using the app. So let's run over the other vitals which are available on Google Play Console. So excessive background Wi-Fi scans. This is a fairly niche metric, but your app may be doing something that necessitates the need to look for particular Wi-Fi networks. And if you do that in the background, then it can drain battery pretty quickly because it's going to be using the device's radio. So this is something that Google discourages. Another one is excessive background network usage, which we'll cover in a little bit more depth later on. But effectively, if you are requesting too much information in the background, then you're probably also going to be draining the user's battery along with their data allowance. So it's probably not going to be a great experience. And there's a couple of other vitals. So slow rendering and frozen frames. Those can kind of be grouped together. If you've ever seen jank in your application, that is when a few frames drop, but then the app resumes, then that is basically what slow rendering and frozen frames relate to. And Google doesn't penalize you on that directly, mainly because there's this ANR called vital, which has an explicit threshold. And finally, there's this concept of permission denials. And this basically tells you how frequently you asked for a permission and it was denied by the user. So this isn't a performance issue as such, it's more of an issue of trust in your application. So if you have maybe 50% of people denying you a permission, then that might indicate there's potentially something wrong with your user interface, and you might want to look into that and see if you can reword the context of why you actually need this permission so that the user trusts you more. So let's move on to our first core Android vital. That is an excessive wake up. So what is a wake up, first of all? Basically, there's this class called AlarmManager, which is primarily used to wake up the device at some time in the future. And then some sort of task will be run. So a classic example of this would be waking you up in the morning with an alarm clock, because that's going to require an exact time, and you can run the task of playing an alert on your phone. And there's a couple of legacy approaches that were used where AlarmManager was used. For instance, if you have an app like Duolingo, for instance, you might want to post a notification every day so that the user can go in and do some revision. So why are excessive wake-ups actually a problem? So we kind of went over this before, but basically, if you set a large number of alarms, you're going to end up draining the user's battery because the device can't go into power saving mode. And in most of these cases, you don't actually care too much about getting an exact time of an alarm, and you care more about just having the work done at some point. And there's superior APIs such as WorkManager, which allow you to schedule these kind of jobs. In terms of the data which Google actually collects for this metric, there's an interesting unit of measurement, which is a battery session. So the definition for this is quite wordy. It's a battery session is a charge from below 20% to above 80%, or from any value to 100%. And in Android 11, it just refers to a 24-hour period. So you can effectively think of this as just some period in which the user had their phone fully charged and then it ran down to pretty much zero. So you can think of it almost as a 24-hour period in reality. The metrics which Google display for this are the number of impacted sessions. So that's a percentage of battery sessions which experience more than 10 wake-ups per hour. So that would be one alarm every 6 minutes. And you also get P90 and P99 values, which can be quite useful if you need to figure out whether there's a certain manufacturer or OS level which is disproportionately affecting you. In terms of a bad behavior threshold, that's the threshold by which Google start penalizing you if you exceed it. As far as we can tell, this seems to be dynamic. And if your app basically goes above the threshold shown on the Google Play Store, it will be in the bottom 25% of the top 1,000 apps on Google Play. There's a few ways which you can reduce excessive wake-ups. Mostly, you can basically just use WorkManager. So for instance, we have a few example tasks here. So if you need to have a user-facing operation from the background, such as alerting the user or posting a notification, AlarmManager is probably still the way to go. So if you've got something which just needs to run in the background, like a scheduled download, then WorkManager might be a good use case. And there's also some extra improvements with WorkManager which you get for free. So the first improvement is batching. So WorkManager is quite clever in that if you have 50 apps on the system all using WorkManager, then WorkManager will effectively schedule all those jobs at the same time between all those 50 apps. This is much preferable to those apps setting an alarm at a time of their choosing, as it allows for greater periods where the device isn't using the battery and is therefore able, or where the device isn't using the radio, so is able to save battery. There's also a couple of nice features such as persistence. So if a device reboots, WorkManager remembers any jobs which you've set, which isn't the case with AlarmManager. And you can also add additional criteria. So Google Photos is a good example of this. So it will only back up your photos if you have a Wi-Fi connection available. And that's both to save your data allowance and to reduce battery usage. So let's move on to core vital number 2, stock wake clock. But first off, what is a wake clock? So if you've used the PowerManager API before, then basically this is a mechanism where you can keep the CPU in an intensive mode after a device's display turns off. So there's a couple of reasons which you might want to do this, but I imagine for most applications this won't apply. One example of a wake clock is just to keep the screen on for something like kiosk mode or a game or a movie. And again, this is kind of a legacy approach, so it might be lurking in your app if you have not reviewed this in a few years. So there's modern alternatives such as supplying the screen on attribute. And one other example I can think of is if you need to keep the CPU on to communicate with some Bluetooth peripheral. And again, there's probably better ways of achieving this these days. So a stock wake clock is a problem effectively if it's held for a long time while your app's in the background. And the reason for that is that your device will never be able to go into power saving mode if that's the case. So Google collects similar information to excessive wake-ups for stock wake clocks. The unit of measurement is the same, it's just a battery session. So that's effectively a period in which a user has charged their phone and then their battery has more or less run out. In terms of the metrics Google collects for stock wake clocks, the metrics use the percentage of battery sessions that had a wake clock held for at least 1 hour. And there are 2 thresholds for bad behavior, which are static. So the first bad behavior threshold is when you hold a wake clock for at least 1 hour in 0.7% or more of all battery sessions. The second behavior threshold is kind of the same. So it's 0.1% of battery sessions where the app was only running in the background. So effectively what Google is saying here is that they really, really don't want you to hold a wake clock if your app was running in the background, because that's really going to drain the CPU and lead to a bad user experience for the Android device owner. And only allowing it for 0.1%, it gives you a very small margin for error. That's 1 in 1,000 sessions in which you can hold this wake clock in a bad way. There's a couple of ways where you can try and reduce stock wake clocks. So there's APIs in the PowerManager interface, which allows you to detect when a wake clock is actually taken out via a callback. And we've got a few examples here of things which might be using wake clocks in your application. So if you're trying to keep the screen on, you could supply the screen on attribute either in your Android manifest or your window manager layout params. So that's kind of the modern alternative. And you could also just, for example, with communicating with a Bluetooth peripheral, you could refactor that protocol of communication and make it a bit more resistant to allow the client to drop out at any time. Let's talk about our third core vital, which is crash rate, something you may be familiar with. So first, let's just talk about what a crash is. Basically, a crash is a coding error that immediately kills your app. On Android, you'll either get a Java crash or a Kotlin crash. And if your app uses the NDK, then you might also get C or C++ crashes. And sometimes, even if you just write your code in Java, you can get third-party libraries bringing in these NDK crashes to your application. So crashes are not a great experience as a user, particularly when you're in the foreground. It is very visible. If your application crashes, it takes you right back to the home screen and it completely disrupts your normal flow, which is one of the reasons why Google wants to disincentivize them. Background crash, you can kind of get away with a little bit more, but depending on what state your application is in, you might end up with some form of data loss, and it's not great, basically. So the data that Google collects for crashes are measured in quite an interesting unit, actually. So Google measures crash rate according to a daily session. So a daily session is a day in which your app was used on a device. So there's quite an important bit of nuance here. If your app is opened 50 times in one day by one user, that still only counts as one daily session in Google's eyes. So it can lead to your crash rate giving you a lot less tolerance for error than you might think. In terms of the metrics shown on the Google Play console, the metric is basically the number of crashes, that's JVM and NDK crashes, divided by the number of daily sessions. There are two thresholds for bad behavior, after which Google will start downranking your app. So the first threshold is when at least one crash happened in 1.09% of daily sessions. So that's around 99% of your users who basically have to be crash-free every day. The second threshold is when two or more crashes happened in 0.18% of daily sessions, which is a lot stricter. And just to recap, the fact that a daily session is effectively just any time that a user opened your app on a particular device in one day means it's really strict. Only 1 out of 92 devices that launch your app can have a crash per day, and that's even stricter for the other threshold. So Google really want you not to crash your app. We have a little diagram here which kind of illustrates this. So we have 3 users who have launched the app 5 times each. And if we look at the crash rate, it's quite different. So our first user on the left opened the app once successfully and then failed to open it 4 times due to a crash. Our middle user had 1 crash at first, but then 4 successful sessions. And our user on the right experienced the same. So if we were calculating the crash rate by the total number of times the user opened the app, it would be a 40% crash rate, which really isn't great, but it's a lot better than the metric which Google use. where the crash rate by daily sessions, that is any time a device opened your app, would be 100%. So it's a lot stricter. There's a few things which you can do to reduce crashes, many of which you'll probably know, but we'll just run over them briefly. So you can review the stat traces, which are provided by Google Play Console, and if you're lucky, you can try and reproduce that crash locally with an emulator or device. And you can also review stat traces with additional data from solutions like Firebase Crashlytics and other third-party monitoring solutions, which usually have a little bit more context and help you debug the problem with that context. Let's talk now about our final Android Vital ANR rate. So for anyone who doesn't know, an ANR is effectively when the application is not responding. And the root cause of that is your main thread is doing too much work and the user interface therefore cannot respond. On Android, if you block the main thread for about 5 seconds, then this dialog shows up and the user is given the option of either killing your app or waiting for it to respond. So an ANR, it can effectively be thought of as a frozen experience. A user could, in an e-commerce app, go to a checkout, and any one of these things could happen to produce an ANR. There might be some network call with a big JSON body which is unintentionally passed on the main thread, and that might block the main thread and trigger an ANR. You might have a third-party SDK which is misbehaving, or any number of these things really, which can make it very hard to diagnose compared to a crash. ANRs basically stop users from interacting with your app, and in surveys, they are just as bad, if not worse, as crashes. Because with a crash, at least you can go back and relaunch your app. And because ANRs stem from so many different causes, whether it's a third-party SDK or just performing too much work on the main thread, it can be really, really difficult as a developer to know where to start and where to solve these. In terms of the data which Google collects on the Android operating system itself, Google effectively captures a single stat trace right at the end of an ANR. So in our diagram below, we have an app which is running normally, then the app freezes, possibly due to the user navigating to a new screen where we need to load lots of information. And during this period of an ANR, the user can't interact with it. And that might go on for 5 or 6 seconds, let's say. And at that point, the Android OS will capture a stat trace of the main thread, and the app will eventually be terminated, or the user can choose to wait. But the problem with that is you only really get the insight into the very end of what's happening at an ANR, and you don't really get the cause, the initial cause of it. So the data which Google collects for ANRs on Android Vitals is kind of similar to crashes. The unit of measurement is a daily session. So that's any day in which your app is used on the device. And the metric is the ANR rate. So that's the number of ANRs you get divided by the number of daily sessions. There's 2 bad behavior thresholds, which it has in common with crash rate. And effectively, when at least one ANR happened in 0.47% of daily sessions, Google will start downranking your app. And it's a similar story for the other threshold, except for when 2 or more ANRs happened, the threshold is a little bit lower. And this is probably why so many people struggle to reduce ANR rate. It effectively means that only 1 out of 213 devices that launch your app any day can have an ANR. and that's a really, really strict threshold to actually meet. There's a few accepted ways to try and reduce ANRs. You can try and minimize your network operations on the main thread. So most people won't be performing network calls themselves on the main thread, but one common pattern that we've seen is you can end up passing JSON on the main thread once you've received a response. So that's definitely something to see if it affects your code base. There's a few other things. For instance, if you're performing any file operations on the main thread, so reading or writing to disk, that's definitely something to avoid, particularly on older Android devices where the device may not have a very fast disk. File operations can take potentially seconds, and it's often quite variable in performance. So it might show up in production, but not on your device when you're testing it locally. You can also try and minimize the amount of synchronization which you need to do on the main thread with other threads. So if you're waiting on some data, which is fetched in some complicated class, which takes 100 milliseconds or so to run, then you might want to think about some sort of fallback UI or something like that, rather than having to block the thread. And you can also try and reduce your ANRs by just getting better visibility into how your code is actually performing in production. So we'd like to take a little bit of time to talk about how Embrace helps you solve crashes and ANRs and how you can reduce the effects of the bad behavior threshold on your application with Embrace. So a quick intro to Embrace if you're not familiar with us. So we are a mobile observability and analytics platform, and we aim to give you the data that you need to drive decisions for your business. One of our key differentiators is that we collect 100% of the data from 100% of user sessions. So you can get the full context on what happened with a crash or an ANR. And we allow you to take that data and segment it across the attributes which you care about. So a particular region, a particular device manufacturer, etc. And we allow you to set up powerful alerting, which will on these metrics, which allows you to reduce the time required to resolve an issue. So older SDKs such as Firebase are typically based on a concept of event-based monitoring, where they capture a crash or an ANR, and they don't really capture the context around that. So the data collection is fairly limited. Whereas at Embrace, we capture the entire session. So you get insights into the technical reason behind the crash, but also what the user was doing and that hidden context on why it happened. And our SDKs are built exclusively for mobile. So now we're just going to have a quick demo of Embrace, and I will switch screens. So this is the Embrace dashboard, which is just a list of user sessions, and we'll run through a user session in a little bit of time. But first off, as we're talking about Android Vitals, let's have a look at our crash summary. So this is a representative example of what you might see in Embrace if you care about crashes. So you have your key summary metrics, such as crash-free sessions and crash-free users. And you can have a look at all the crashes which are impacting your application. We also have we allow you to click into individual crashes. And for this crash, you can see that there's something going wrong with Google ad requests. So this might not be something that we want to directly assess or directly fix ourselves. There might be a conversation we need to have with a third-party SDK. And alongside a stat trace, you get various other useful bits of information and metadata which you can filter on, such as what the state of the app was, the device manufacturer and OS version. And one interesting thing is you get a lot of context on whether a crash was overrepresented in a particular device or a particular OS. And this can be quite useful as you can effectively make a business decision about whether it makes sense to support older versions of an operating system. If you're over the bad behavior threshold and Embrace shows you that a particular device is pushing you over, then it may make sense just to drop support for that device rather than resolving the actual issue. It may be a much quicker solution and not cost you that much. So we can have a look at opening the user timeline to get additional context into this particular crash. So if I click on to open user timeline, that would show me the session timeline, which effectively shows what the user has done. So effectively in this application, startup has been a little slow, and we can also see the same information here that we do down in the timeline. And we'll capture a bunch of information really. So we capture the active screen, we capture network requests, first party and third party, and you can get information about when they took a long time and when they failed. And there's also information about ANRs, which I'll show in a little bit. So again, this is a summary of all the crashes in our application. And this effectively shows us that certain devices are definitely overrepresented, and this is fairly configurable. So you can show what the last captured view was before a crash, which might indicate that a particular activity is buggy and you need to ask your developers to go and have a look at it. And you can see whether certain countries are overrepresented in crashes. So I'd also like to show you the ANR summary page. So as I alluded to earlier, we show ANRs in a slightly different way to Google. So whereas Google just captures the stat trace towards the end of an ANR, we capture stat traces throughout the duration of an ANR, which allows us to build a flame graph. And we group those flame graphs on package. So for this example, this would be an ANR happening in this particular package. And this is what the flame graph looks like. So this is a really interesting way to look at ANRs. Rather than looking at a stack trace, you're effectively looking at how long each method took. So for instance, here we can see that there's always going to be system calls because the Android OS needs to schedule work in your application. But once we get down to ANRs to methods such as these, we effectively find out how long each one took. So effectively, we want to go and look at the largest chunks in here. So we can see that executing the lifecycle state took a long time. So we might want to investigate whether there's anything we can do to optimize that. We can also see that coroutines are taking a while. So we could get the stat trace from here and see whether there's anything we can do to optimize that. In addition to showing an ANR flame graph, we also have summary stats similar to the crash rate. So we can see that certain devices, this one in particular, are vastly overrepresented in ANRs. So if that's the case, and you see similar data with Embrace, and you're struggling with your ANR metric on Google Play Console, then it may be worth considering dropping support for certain devices. And again, this is just another example of the flame graph. So we can see that something is going wrong here with a coroutines callback. So that's perhaps something we can ask our developers to go and investigate. Okay. So we hope that shows you that you can help solve the toughest crashes from Embrace. But we show various metrics, so crash counts and also their representation across different OS versions, devices, regions, and more. We hope we showed you that there's fairly powerful filtering that allows you to figure out the crashes which you actually care about. And with each crash, you can get that full context on the session by opening the timeline of what the user has actually experienced. Similarly, for ANRs, we hope we've shown you the similar. You can see ANR counts and aggregate metrics, and you can also find out whether particular versions, operating system versions, devices, and regions are overrepresented. So instead of just getting one stack trace from an ANR, we perform distributed stack trace sampling, which is what that flame graph shows you, and effectively shows you how slow each method is. So the larger a method is in a flame graph, the more likely it is to be impacting your application's performance and contributing to an ANR. And the more likely it is you want to go and investigate that particular method. So just to sum up, here are some key takeaways. So Android Vitals are really important if you want to improve your app's ranking in the Play Store, and that's fairly critical to success these days. The Google Play Console does have some helpful metrics for allowing you to track the big picture, but personally we feel it doesn't quite provide enough data to solve all the thorny issues, particularly on ANRs. We feel there are better solutions. And getting to the bottom of those toughest issues can really require the full context on what's been happening in the user session. Sometimes it's just invaluable being able to see what a user did in the lead up to a crash and eliminating the guesswork. And we hope we've shown that Embrace is purpose-built for optimizing performance on mobile and helping improve the stability of your Android apps.